Good good afternoon to Mr. Ting. Welcome to project demonstration of group 14. And this is my group member and the following ID. My name is Hugh Jian and I'm in charge for member Z. And the second one is Alexandro. He is in charge for the member Y. And then lastly is Chong Kai Cheng, which is our leader, is in charge for the member X. So next. Okay, now I pass my mic to member X to let him to discuss his final conceptual design.
Thank you, Hugh. As a final conceptual design of member X, I renewed the flowchart, which is the first one, the clamp will remain still and it will reverse to prevent the red part goes in the collecting mechanism, which allows the red part doesn't be picked up. Next is both clamp will move 90° clockwise or anti-clockwise in order to collect the part in the arena. Last but not least is it will end, the program will end at the 180 seconds or 3 minutes. Next. Now I'm going to pass my mic to member Y.
Thank you, Kai. So as you can see, this is my final conceptual design for member Y. So here are some readings that I have taken, like sample readings, varying the distance. We try to keep the lighting around an average of 30 to 40. Here are some samples. Actually, it's not everything that we tested. This is only a small portion. Next. As you can see, this is the summary. So we took the lens from 6 to 8 because the other values seem to be overlapping, such as 4 centimeters, 3 centimeters, and the light intensities we managed to keep at constant. And this is just 10 tests, but we actually did more than 10, like around 30 to 40. Yep. Next. Alright, I will pass into Hugh, who is member Z.
Okay, thanks Alex. So now I'm going to explain my final conceptual design for member Z. As you can see, that's the motor port for line 4 until 7, which means that 4 until 7, the code will be four digital, like 000 four number. Yeah, and then I spread it by 4 until 5 and 6 until 7. 4 until 5 is the left wheel and it is produced to a right turning. And I observed that 0.5 seconds it will turn at 90°. And same go with the right wheel. And the black and the red will be using these functions, this both function, and also stop and reverse. And the middle ones, forward a while and stop reverse, will be using the 4 until 7, the port 4 until 7, and the color will be using which is white, blue, and yellow. Okay, next slide. Okay. Also, furthermore, I have designed the movement strategy for the robot, and when the robot, sorry, I mean the sensor, when the sensor is detecting the black tab, it will moving forward and then reverse, and then it will randomly select left or right turning. Same go with the yellow and the red pub. However, for the blue pub, it will move forward and then after detected, it will stop for a while in order to let the servo motor to pick it up and send it to the collection area. So now I'm going to pass my mic to Alex, let him explain the final combined conceptual design.
Thank you, Hugh. So as you can see, this is the final combined conceptual design. This is more like the flowchart for the main script.
I think you're on mute.
sorry. So this is the final conceptual design. So this is the flowchart for the main script. So as you can see at the beginning, the constants of the global variables are being placed so that the other functions can be easily, the variables can be used. Later on, you can see that there's a while loop where I have constrained using a time function to detect the 180 seconds for the TikTok. And next, what I did was I placed a loop for the readings be taken 1 to 20. And then what I did was I used another condition whether the readings are in the range of the values that I want, more like now. And so after that, the actions of the colors will pass to the actions such so, and the following is being taken till the 100 seconds are gone. Next. Next. Alright. So I will pass into Kai Cheng, who will be talking about his member X assignment.
Thank you, Alexandra. For member X design improvement, as you guys can see in the first picture, I used the big gear as a first design of the collecting mechanism. It is big and hard to be installed. When I change it to the small gear, as you guys can see in the second picture, it's easy to be installed and easy in moving the clamp, as it will not jam when closing the clamp and opening the clamp, and collect the part successfully in the video. Thank you. Next. Now I'm going to pass my mic to member Y.
Thank you, Kai. So as you can see before, when we took the readings of the light intensity, we just took it to one direction as the robot was facing towards one direction, which is up. So I thought that this won't be accurate because the robot here and there should be considering other directions. Therefore, I made my member X to take the light intensities across the whole arena, which is north to south, which is up and fro, and west to east, which is side to side, so that the readings of the light intensity would be average as we move the arena here and there. So then the best position for the sensor will be available. Next. Another improvement was that earlier I just took just one random distance, but after that I realized that distance is also a big challenge. So therefore I took several readings so that the best uh, sensor values be available so that no overlapping. Yeah. Next. All right. I will pass into you, GN, whose members it.
Okay, thanks, Alexandra. Now I'm going to explain my design improvement. At the previous script, as you can see, I have been put all the movement inside one function file, and then after I knowing the power modulations, and then I separate it by 4 movement, and the 4 movement consists of forward, backward, turning right, and turn left, and all this movement will be stored inside the main script to let the robot move successfully. Okay, next slide. So we're going to step inside the design creativity. And now I'm going to pass my mic to member X.
Thank you, Hugh. As a design creativity of member X, I use different design to install the sensor on the robot. As the last final design creativity, I install it horizontally under the clamp, as you guys can see in the first picture. is it can directly scan different color part without being blocked by its own shadow and get an accurate reading. As you guys can see in the second picture, and why I used a big cross on it is that when the sensor is installed from up to downwards, it will scan its own shadow, thus making our data goes crazy. It is because the light intensity is being blocked and the shadow of the sensor blocked it. Next. Now I'm going to pass my mic to member 1.
Alright, thank you, Kai. So for my creativity, what I did was I just selected the best ranges out of the whole my summary of the data tabulated before, and I made sure that the sensor reads the correct reading. So I made it the concept of binary. So then, since we do not have a GUI, like accessing ones and zeros will be easier for my other members. So it's going to be simple and efficient. So this is why I thought of. Next, I'll pass it to you, Zach.
Okay, thanks Alessandro. Now I'm going to explain my design creativity for members. So as you can feel easy to let me explain for this scenario. And I have changed the forward in while loop change to become forward a bit. Means like it will move and stop, like the figure, the bottom one. And then for these purposes is on to synchronize with the sensor, and it can this movement we can slow down a bit for the sensor to take the reading more accurate. If we are using the while loop, it will move forward very fast, and then the sensor will be taken the inaccurate reading, and sometimes it will like move out of this arena, and this is the situation that I want to avoid too. And it was also it move forward a bit will be stay about 50 cm and stop for a while. So when the value of black is detecting in 1, it will backward and random movement of or right or left. Okay, next slide. Okay, now we step into the last sections of our presentation, which is the demonstration video. Now I'm going to play this demonstration video. Okay, thank you. That's all from us.